Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today we're going to be doing Unit 8, Lesson number 3 on Basic Exponent Properties. Now, I know we've had multiple lessons on exponents so far, but quite a bit of this course is centered on the idea of exponents, whether it's exponential functions, logarithmic functions, fractional exponents, or a variety of other issues. It's important that all of the major exponent properties or rules or laws or whatever you want to say are fluent within you so that you can deal with them no matter what comes in terms of exponents. And we're going to have some beastly ones in the next few lessons. Today what we're going to be doing is reviewing all of the major exponent properties except for fractional exponents, which we'll take a look at again in the next lesson. All right. Each one of these should be familiar to you, but we're going to go through each one and develop it sort of somewhat from scratch. Let's dive right in. All right. Exercise number 1, property number 1. Consider the expression x to the a times x to the b. How can we rewrite this product equivalently? Well, letter A says rewrite x squared times x to the fourth, write as an extended product first if necessary. Pause the video now and go ahead and do that. All right. Well, you probably don't need to write this as an extended product, but if you do, right, x squared is x times x, right? X to the fourth is x times x times x times x. And because multiplication is associative, we can remove those parentheses and regroup as the following, right? And then that's x to the sixth. How can we generalize that? What's the rule? X to the a times x to the b is x to the a plus b. All right? And that's nice because then we can take something like this, x to the 10th times x to the third, and we can automatically make it into x to the 13th. Now what happens if we have something like this? Well, 5x to the fourth times 6x cubed, again, because of multiplication's commutative and associative properties, we can eventually rewrite this as 5 times 6 times x to the fourth times x to the third, which is 30x to the seventh. All right? Why don't you go ahead and do number 3? All right. Well, again, this can be confusing because of all the different variables, but again, because of the associative and commutative properties of multiplication, we can swing it around. So x cubed times x to the sixth is grouped together. Y squared times y to the first is grouped together, or are grouped together. And then that would become x to the ninth, and that would become y cubed. And there is no way then to make that somehow like to the 12th, because we're not multiplying by the same thing 12 times. We're multiplying by x 9 times and y 3 times. All right, property 1 of exponents. It's the one everybody learns. First, that is. All right, pause the video now, write down anything you need to, and we'll go on to exercise 2. Excellent. Let's do it. Exercise 2. Now we're going to do division. If we can do multiplication, we can do division. Consider the expression x to the a divided by x to the b. How can we simplify this quotient, this division problem? This is a little bit different and a little bit harder for students. Letter A says rewrite the quotient x to the fifth divided by x squared in simplest form by using property 1 and the multiplication property of fractions. So real quick, let me just remind you that when you multiply fractions together, let's go with fractions that you'll feel more comfortable with. 2/3 times 5/7, you simply multiply the tops and you multiply the bottoms, giving us eventually, in this case, 10/21. But that property can actually be used sort of in reverse to unmultiply fractions. In other words, x to the fifth divided by x to the second is equal to x squared times x cubed divided by x to the second, which then would be x to the second divided by x to the second times x to the third divided by 1. Let me get rid of all of this. Let's try to do that one more time. There we go. Go back to my pen. X to the second divided by x to the second is equal to the number 1. Anything divided by itself other than 0 is equal to 1, and we just get x to the third. All right. Now, most people ultimately will do something like say, well, 2x's down here will cancel 2x's up here and leave us with x to the third. But ultimately, what's our rule? X to the a divided by x to the b is x to the a minus b. Now be careful, because when we work with quotients, right, then we've got subtraction of powers involved, and when we have subtraction involved, that's not commutative anymore. Now it's still easy enough. X to the 8th divided by x to the 2nd will be x to the 8 minus 2, which is x to the 6th. That's no problem. When we have something like this, 6x to the 10th divided by 12x to the 4th, it's good again to use that multiplication property of fractions to actually, if you will, unmultiply this, right? To look at it as 6/12 times x to the 10th divided by x to the 4th. We should all feel comfortable with the fact that that's 1/2, and then this is x to the 6th. So we could either leave our answer as 1/2 x to the 6th, that's a good way to write this, or x to the 6th divided by 2. All depends on how we want our final answer to be left. Now when we have something like number 3, or subletter 3, or however you want to call it, I don't care. When we have something like this, again, using that property of saying, well, let me break it up as x to the 6th divided by x to the 1st times y to the 3rd divided by y to the 2nd, well, now this thing can be written as x to the 5th, and this can be written as y to the 1st, right? Just by subtracting exponents. Now it's really important. We are always doing the numerator's exponent minus the denominator's exponent. And in each one of these cases, what happened was that the numerator's exponent was larger than the denominator's exponent, all right? And therefore, we ended up having a positive final exponent. We'll talk about negative exponents in just a little bit. Pause the video now then, and write down anything you have to. Okay, I'm going to clear out the text. Let's go on to property number 3. All right, but what if the power in the numerator is less than the power in the denominator, right? So letter A says rewrite the quotient x squared divided by x to the 5th as in exercise 2a. And I know we don't have exercise 2a sort of like sitting here at this point. But in other words, we can take this and we can rewrite it as x squared divided by x squared times x cubed. Now we have to be careful, because this would then be x squared divided by x squared times 1 divided by x cubed. Now I'm going to pause for a minute. I want you to look at that. Just make sure you feel comfortable with that, right? Certainly if we multiplied these two together, we would definitely have that. So here we're kind of unmultiplying. But again, x squared divided by x squared is equal to 1. This is just 1 divided by x cubed, so our final answer is just 1 divided by x cubed. And again, what a lot of people will say is they'll say, just looking at the original, they'll say, well, 2x's cancel 2x's here, giving me an x cubed. But then some students will make the mistake of saying, oh, well, then our final answer is x cubed. But it's not. It's 1 divided by x cubed. Now, letter B asks, what results if you apply exponent property number 2? In other words, if we use the property from the last problem that says x to the a divided by x to the b is x to the a minus b, well then that would say x to the 2nd divided by x to the 5th is x to the 2 minus 5, which is x to the minus 3. But that means these two must be the same. Okay, 1 over x cubed and x to the minus 3 must be the same quantity, and therefore generalize x to the negative a is 1 divided by x to the a. And that's really the property, right? And that's the property of negative exponents. Negative exponents indicate division by that base. So, real simple, letter D, rewrite each of the following without the use of negative exponents. Well, 2 to the minus 3 then would be 1 divided by 2 to the 3rd. And actually, technically speaking, that's a fine way to leave it. If for some reason we needed a final numerical answer, 2 times 2 times 2 is 8. So 2 to the negative 3 is 1/8. And you saw a lot of this in our work in the exponential unit and the method of common bases and all that stuff, logarithms. X to the minus 4, that's simple, 1 over x to the 4th. All right, so property 3 deals with the definition or the notion of negative exponents. Pause the video now and write down anything you need to. Okay, clear out the text. All right, exercise number 4. What if the powers are the same? Right? I mean, we've looked at division when the numerator's power is larger than the denominator's. Then we looked at division when the denominator is larger than the numerator's power. What happens if the powers are the same? Well, I mean, this is kind of silly, right? X cubed divided by x cubed is 1, right? The fundamental concept of dividing a quantity by itself, right? This is fine, as long as x doesn't equal 0. 0 divided by 0 isn't 1. But what would happen if we apply exponent property number 2? Again, that was x to the a divided by x to the b equals x to the a minus b. Well, if we do that for x to the third divided by x to the third, we would have to have x to the 3 minus 3, which would be x to the 0. But that means these two things must be the same. And this is the idea of the zero exponent. Any quantity to the 0 is equal to 1, except 0 to the 0. That doesn't equal 1. But anything else, so x to the 0 equals 1 as long as x doesn't equal 0, right? Very important property. 5 to the 0, 10 to the 0, x to the 0, y to the 0, they're all equal to 1. Simplify the following. Well, 5 to the 0, that's 1. Now watch out here. Pause for a minute. What would 3x to the 0 be? Well, if you said 1, then you're not thinking enough about order of operations. Right? Order of operations would say that we have to do that exponent first. So x to the 0 is 1. Then we do the multiplication and we get 3. Now, contrast that versus 3x to the 0. Oh, that would definitely be 1. Right? Because then that's just something to the 0. But here we have 3 times something to the 0, so that's 3 times 1, which is 3. So the 0 exponent, that one's always been weird, right? Something to the 0 is 1. But then that makes exponent property number 2 work out again and again. All right, pause the video now. Write down anything you need to. Okay, let's clear out the text. Property number 5, something to an exponent raised to an exponent. Letter A, rewrite x squared cubed, write as an extended product if necessary. All right, well, as we know, something cubed means we're going to multiply it by itself 3 times. But then we can apply exponent property number 1, which says that's going to be x to the 2 plus 2 plus 2, which is x to the 6th. So what's the generalization? X to the a to the b is x to the a times b. We've used that property a lot this year, a lot. Take a look at the multiple choice question in letter C. Which of the following expressions is not equivalent to x to the 30th? Think about this a little bit. Did you figure it out? It's choice number 3, right? X to the 5th times x to the 6th is x to the 11th. All the rest of them are x to the 30th, right? This is 10 plus 20, 30. This is 6 times 5, 30. This is 10 times 3, 30. So just choice 3. All right. Very important property, right? It's the property that's really going to help us understand fractional exponents a little bit better. All right. But pause the video now. Write down anything you need to. Okay, let's clear it out. This is an ideal lesson almost to be doing on your own, as kind of almost a flipped lesson because you've seen all of these properties before. But let's do a little bit more. All right. Our last properties 6 and 7, have to do with what happens when we have a product raised to a power or a quotient raised to a power. Now this is pretty easy. Rewrite x times y cubed using the definition of an exponent along with the associative and commutative properties of multiplication. In other words, xy to the third would be xy times xy times xy. Simple as that. But because multiplication is associative and commutative, I can rearrange this as x times x times x times y times y times y, which means I'm going to have x cubed times y cubed. So what's the generalization? If we have x times y to the a, we have x to the a times y to the a. Now that wouldn't work with the sum, by the way. I really want to emphasize this. If we had xy to the x plus y to, let's say, the third, we would not get x to the third plus y to the third. But if that's a product in there, then it works out just fine. All right. Likewise, with a quotient, x divided by y cubed, using the definition of an exponent along with the multiplication property of fractions, well, this one's even easier to see. X divided by y cubed would be x divided by y times x divided by y times x divided by y. But then multiplying fractions tell us we have to multiply all the numerators together, which is x cubed, times all the denominators together, which is y cubed. And therefore, x divided by y to the a is x to the a divided by y to the a. Okay. Now we can use all of this, plus other exponent properties, to simplify or to rewrite the following expressions a little bit better. All right, so let's tackle them. In this last problem, we've got 2x squared cubed. Right, this is really an application of property number 6, if you will. This is going to be 2 cubed times x squared cubed. Well, 2 cubed is 8, and x squared cubed is x to the 6th, right? Because we use that property that says multiply the exponents. 3 divided by x squared squared would be 3 squared divided by x squared squared, and that's going to be 9 divided by x to the 4th. Ooh, finally, and this is the biggest one of them all, right? And let's try to do this all without having to write out this first step. We'll have negative 2 cubed. That might be the hardest part of this problem. Negative 2 times negative 2 times negative 2 would be negative 8. X squared cubed, right, would be x to the 6th, because we're going to multiply those exponents. Y to the 5th cubed would be y to the 15th. 3 cubed would be 27, and z cubed cubed would be z to the 9th. And that's the beast we have there. All right, so just a nice little review of products and quotients within powers. Pause the video now and write down anything you need to. Okay, I'm going to clear it out. And let's wrap it up. So in today's lesson, we really did nothing new, and I know that can be a bit frustrating, but at the same time, students' abilities to manipulate exponents fluidly, right, and confidently is extremely important at the Algebra 2 level. Again, whether you're dealing with the method of common bases or evaluating a logarithm or simplifying a fractional expression, things like that, you need to have confidence with your exponent laws. All right. I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.